Hi, my name is Abdulrhman. In this video, I'm gonna talk about the role of system calls and secure process management. Let's begin. Introduction to operating system. Operating system manage hardware resources like memory, processing power, and input-output devices, serving as the interface between hardware and applications. And for the second one is what are the system calls? System calls are function enabling user application to communicate with the operating system, requesting service like process management, file handling, and device interaction for secure and efficient resource use. So now, uh, types of system calls. For the first one, process control. Process control system calls create, manage, and end the process, including forking new process and running new programs. Second thing, file management. File management system calls enable application to open and read, write, and close files, plus manage direction session operation for data manipulation and access. The third thing, device management. Device management system calls enable the operating system to access and control hardware devices like printer, keyboards, and network interfaces. Fourth thing, information maintains system calls retrieve and set system data like performance metrics, environmental setting, and configuring parameters, search for system monitoring. Now we will talk about the role of system calls and process management. System calls are search and manage the life cycle of process. They provide the necessary function of creating new process, executing them, and ensuring their proper termination, thus maintaining system stably and resource efficiently. Creating and managing processor. For the first one, for creating a new process, the fork system call create a new child process that duplicate the parent process, inheriting its attributes and state essential for multitasking and concurrent execution. For the second thing, exec, replacing a process memory space. The exec family replaces a process memory with a new program, enabling efficient program execution and resource reuse within the same process context. For the third thing, wait, synchronizing process execution. The wait system call makes a parent process pause until its child process terminates, helping manage resources and prevent zombie process for better system stability.
Hi, my name is Bashir Osman Said. Today we're going to talk about our brain station we did in our group. So I have to do my part is here. I will present in my part. This part is talking about the process control block PCP overview. The process control block PCP is a data structure containing essential process information state program counter, memories, details, and resource regulation, enabling efficient process scheduling and execution. Inter-process communication IPC mechanisms. We talk about here pipes enable one-way flow, matched queues stores messages, which stores messages. Shared memory for efficiency. I'm going to talk about the shared memory for efficiency. In here, we're going to talk about how the system calls and enhance security, and also enhance the security. The system calls enforce security by acting as a control interface between application and system resources, and also in securing only authorized process access, sensitivity information, and perform also critical operations, also to protect against authorized access, unauthorized access. Access control and permissions. And here we're going to talk about how the access controls and how it works with the permissions. Understanding the mechanism that enforce user identification, files, permissions, and also rule-based access. In user IDs and group IDs, ensures that every user is uniquely identified, which is critical for managing permissions in a multi-user environment. Also, we will talk about the file permission and how to control access levels for files, and defining who can read and write or execute them, thus protecting sensitivity information. Field-based access controls is also utilize the rules to streamline permissions management and significantly improving security by limiting access to necessary resources only. We're going to talk about here error handling and security checks, how the error will be handled and how will be the security checks will work. First, validating input parameters. Input parameters are validated to ensure proper format and constraints preventing security vulnerabilities like power overflows or injection attacks, and also maintaining system integrity when processing user requests. Checking user permissions. User permissions are checked to verify the process and also has appropriate access rights, enforcing security policy and preventing unauthorized actions to also protect sensitive system resource. Logging errors for auditing. Logging errors is vital for auditing and troubleshooting, also and allowing administrators to detect security incidents and system anomalies by reviewing record error events. So that's my part of my presentation, and thank you very much. I hope you understand what I'm saying very well. Thank you.
Presentation, I'm going to continue from example of system call in action. System call in action. System call enable critical functions in application. For example, and let's start with a real example. And everyone knows when you use a text editor to open a file, it does not just reach into the computer. It asks permission. If uses the open system call to read the file, it uses read. To save, it uses write. This system calls are like security checkpoint. They ensure the app only access what it is allowed to, keeping everything safe and controlling. So case study, secure process management in Linux. So, and how to make, so now let's make this our focus. How does Linux manage process security? It's all comes down to system calls. They they are the controlling bridge between user program and the operating system kernel. Every time a process need resource, memory, files, CPU, time, it must go through this secure gateway. So stand Linux, we also release it, setting the foundation for open resource operating system that prioritize security and performance. And to understand Linux security, we start at the beginning. In 1991, Linux was released. It is open source in Azure, meant that from day one, security and performance were built in its DNA. This sets the foundation for everything that follows. And 2003, introduction of the Linux security model framework, allowing from different security mechanisms to be implemented. Fast forward to 2003, Linux introduced the Linux security model LSM framework. This was a big shift. Instead of one fixed security system, LSM allowed developers to plug in different security mechanisms, making Linux flexible and ready for advanced protection. In 2007, and SEL Linux security and enhanced Linux become a prominent feature, enforcing mandatory access control policies to enhance security. By 2007, one of those models became standard. SEL Linux and enforce mandatory access and control, meaning the system itself enforces strict security policies far beyond simple user permission. This prevents compromised apps from taking over the system. By 2015, the introduction of the namespace in Linux provides process isolation, enhancing security by restricting resource access for individual processes. In 2015, Linux added namespace. This feature allows process isolation, giving each process of container its own isolated view of the system. It is like putting each app in its own secure bubble, restricting what it can see and touch. By 2021, continuous development in kernel security features, including control groups, C group, and improved auditing capability for system calls. And security never stopped evolving in Linux. So by 2021, Linux added even more tools, control group like C group, to limit resource usage and improve auditing to track every system call. This makes the kernel more observable, controllable, and secure than ever. Linux vs Windows system call and security. So what does Linux offer? A transparent role-based security model built into the system calls. Compare that to Windows, which relies heavily on access control lists, ACLs. ACLs are powerful and fine-grained, but they also add complexity. Both systems use system call differently, shaping their entire security approach. So let's conclude this. Conclusion: system calls are essential for secure process management in the operating system. They provide a controlled interface for user application to interact with system resources, enforcing security policies, managing permission, and facilitating error handling to protect against the unauthorized access and ensure the process isolation. So that was all. Thank you.